Start. Hello, everyone. Welcome to the NCFI Geotechnical Polyurethane 101 webinar, discussing the fundamentals. We're at 10:59, or excuse me, we're at 11:59, depending on your time zone. We are going to wait about 1 to 2 minutes before getting started, just to give people a chance to connect right with us. So it'll just be one moment. Hello, everyone. We're just going to take about another 30 seconds or so just to give everybody a chance to log in. All right, about 20 more seconds and we'll get started. All right. I think we can get rolling, Kevin, at least get through the introductions. That should give everybody a chance to come in. I'm going to get started today. I'm your host, talking to you live from the Denver International Airport. So if you hear some fun background noise, I'll just apologize in advance. So today we'll be doing the Polyurethane 101, the Fundamentals webinar by NCFI, the Geotechnical Division of NCFI. We can go to the next slide, please. Just to go into a little housekeeping before we get started. The approximate length of the webinar is 1 hour. There's a chat available. If you look at the bottom of your Zoom webinar, you'll see the ability to chat there. So if you have running into any issues or anything along that lines, please just let me know. I'm going to back up just 1 second, Kevin. There will be a webinar recording that will be sent after the webinar. Typically, it just takes us a little bit to upload it, but you should get an automatic email with that included. And then at the end, we'll be doing a Q&A session. Go to the next slide. So as part of that Q&A session, you'll notice in your browser window, and if you're not seeing it immediately, there's a More button that they've recently added. You'll find the Q&A there. But as questions come up during the webinar, just for time standpoint, we won't be asking them during the webinar, but we will ask them at the end. So the higher backlog of questions we have, the easier it is to ask the questions at the end to make sure that we can take advantage of the time as well. Justin mentioned today's webinar is available for PDH certificates if you so desire. It is a state by state basis as far as its acceptance. I'm certainly able to discuss that or help you out if you have any questions. When you exit the webinar today, it should take you to a survey link. Within that survey link, it'll ask for you to indicate whether or not you would like a PDH certificate. And then it will send you your PDH certificate. But you have to go through that survey and request it. So just want to let you know that. And then we're going to get started. Kevin, next slide, please. All right, I want to introduce our speaker today. Speaker today is Kevin Irwin. He's a territory manager for NCFI's Geotechnical Division, covers the central United States. He's kind of been there, done that in regards to the poly industry. He's owned a geotechnical business. He's served in operations. He's done design. He's been an owner. He's kind of done it all. He joined NCFI Geotechnical in 2019, so he's been with us for about 7 years, and he supports customers all across the United States, but specifically as far as his territory, it's from the Gulf Coast of Texas and North Dakota. That being said, Kevin, I'll let you take it from here.
All right. Thanks, Robert. Welcome, everybody, to the webinar. So looking forward to talking to you about polyurethane. This is a basic course. I mean, the idea is to get the background that you need to to get to build on to get the greater concepts down the road. Real quickly, NCFI, 60 plus years in business. I've got my 60-year shirt on. There you go. But anyway, we just had our 60-year anniversary a couple years ago, and been doing this for a long time. Geotechnical division started in 1990s. Of course, we have research and development in-house, constantly working on products and custom formulations. Quality control, we test every single batch that comes out of our plants, and hold those retains for future testing for a time if necessary. And of course, logistics, our buying power, all those things, supply chain, all those things. We're as a large company, we're able to keep those things flowing pretty well. We also have a great customer and technical service team. We have logistics support for shipping, field technical support, Ronnie Simmons, Steve Barnes on our geotech team, project design help from any of us on the team, and of course, training classes as well. So we're going to start off talking about polyurethane chemistry. Dual component polyurethane systems have an A side and a B side. So there's, I like to tell people, I work for a polyurethane manufacturer, and I'm out there dealing with foam all the time, but I don't sell foam. I sell the chemicals to make foam. The foam is made in the field when these two components are mixed at the proper pressure, temperature, and ratio. So the A side is a standard kind of chemical. It's isocyanate, MDI, or ISO. A side, most people call it. That's a standard chemical that we purchase. The B side is the resin. That is where the magic happens, and that's where the formulas change. So that's our proprietary information there in the B side. Mixing of two component systems should be 1-to-1 by volume. That's by volume of A to B. So the drums may weigh differently, but they'll have the same volume of chemical in them. Heated 100 to 130, is a general range for most systems. But all of our technical data sheet information is from chemical that was shot at the 110 degrees. So that's kind of our baseline there. And then a proportioner that maintains that 1-to-1 volume is key to making good foam. And we want to make sure that pressure as you're pulling the trigger or as you're injecting doesn't drop below 800 PSI if you're using an impingement mixing gun. Now, there are single component polyurethane systems as well. We sell a number of those and are developing those systems as well. These are our primary system, the NCFI 120. Is pre-polymer with MDI and catalyst already in it, so it will react with moisture. But these single component systems, you don't run these through a proportioner. These are, even though it says MDI, which is the A side of two component foams, MDI doesn't mean that this would replace the A side in your proportioner. So just make sure that it's typically installed with a paint sprayer, airless paint sprayer, or cartridges. So one main component plus the catalyst, and that catalyst can be added, but it doesn't react until it hits water. And I want to back up real quick because I didn't say that up here. Two component systems, they do not need water to react. In fact, everything that's needed to make these two components react with each other is contained within the drums, the A side and the B side. Water can't affect it, but we'll talk about how in a bit. So we're going to look at density. So our density, I'm sure many of you have heard the terms 2-pound foam, 3-pound foam, 4-pound foam. And what that means is it's if you had a cubic foot of that chemical at its free rise density, which we'll talk about packing here in a minute, but that density is going to be, if you had a cubic foot of the material, if it was a 3-pound material, that cubic foot would weigh 3 pounds. You put it on a scale, and it would weigh 3 pounds. If you have a 4-pound system, free rise density, sprayed perfect conditions, that would weigh 4 pounds. 2-pound system, the same. So density is going to be our weight per cubic foot is what we're going to be looking at. Why is that important? It determines how much chemical you're going to need to fill a void or lift a slab. It affects how much material is needed to complete the project. In other words, all of my estimating is going to be done based on that density information and some other things. It's the single largest determining factor of a foam strength properties as well. So density is going to be very important to us as we move through this. And we got to talk about 2 main types of density. Free rise density first. Think of it as a minimum density as designed by the manufacturer. It's not technically that. I may actually get in trouble for saying that by the lab, but anyway, the free rise density is as designed in the lab and unconfined or unconstrained during the reaction. So it's important if you think back to me saying I don't sell foam. Foam is manufactured in the field. Well, that's true. I sell the chemicals to make foam. And what's neat about that is that as the foam is being manufactured in the field, right, you pull the trigger and those 2 liquids go into the ground. And they stay liquid for a certain amount of time. Depends on the system you're using. That as the chemical expands to fill voids, or maybe it doesn't find much void and it starts to lift, but as it expands, it conforms to whatever shape you're injecting it into. And so that's really key as you think about it. The free rise density, this is the density that you would have if you sprayed the chemical directly into a box on the ground, into wherever it is where it's not confined. And contrast that with confined density. Anytime you put a box around or a slab on top or soil around the foam that you're injecting, which as geotechnical folks, that's most of the time, I would think. As the chemical begins to expand, it expands into void, right? And that void is going to be closer to the free rise density. And that's why you want to know what that free rise density is, because any voids that are filled are going to be filled at that free rise density value. But then as it starts to expand and then it hits the confines of whatever it's in, so if it's in the ground or under slab or whatever, it tries to expand and it can't. And so there's bubbles being created inside the foam as the chemical reaction occurs. And so those bubbles tend to start to get smaller. The foam becomes more dense as it builds density and builds pressure in order to either fill void or lift. So here's a visual on that. Packing of foam as I inject it into a void underneath a slab. You can see that's going to be closer to my free rise density. As it begins to expand and change, and you can see I'm still putting more liquid in, even as the previous liquid has already turned to foam and has been expanding. And so we'll fill voids in that one area, and then as it hits the edges of where it can go, the last path of least resistance is going to be up. And so that's how confinement helps us. So, what this means is that a 2-pound foam or a 3-pound foam is going to become more dense than that 2 or 3 or 4 or 5 or 6 or 8 or 12 pounds, whatever the free rise density of the system that you're using is. When you put it in a confined space, it is going to become more dense. How much more dense is a great question, but we get good at estimating that. We also do in-house testing. These are the ASTM tests for compressive strength, density, tensile, flexural shear strength. And then at the bottom there, GTP9 test for hydrophobicity. It's kind of the de facto standard. There's not an ASTM test that I'm aware of for that. So industry standard is GTP9 to test for hydrophobicity. All right. We have available NSF ANSI 61 certification. So this is available. It's by default on the NCFI 120, our single component systems. On our two component systems, at the current moment, it is by request only, but it is available. That means that if you have a customer that is concerned about water sources and that kind of thing, we can make the foam in a way that conforms to the NSF standard, ANSI 61. Now, curiously, there's absolutely no chemical difference between an NSF certified system and a non-NSF, and it's not certified; it just meets the standard. But that standard is going to give you it's going to give you the ability to shoot around those water sources and don't have to worry about any leaching of any kind of chemicals or that kind of thing into a water source. Now, as the chemical reacts, so I pull the trigger, my pumps start working, it starts sending the A and the B all the way down the hose, whether I have a 50 feet of hose on my rig or I have 300 feet of hose on the rig. Those chemicals stay separate all the way until the very tip of the gun. Right before it comes out the tip of the gun, whatever you're using for an injection gun, that's when the chemicals mix. And it's at that time that we can say, okay, well, our chemical reaction is going to begin very quickly. So that first phase it goes through these different phases: cream, gel, tack-free, and rise during the chemical reaction process. Cream time is when expansion begins. So this is, you're going to see liquid, and then you're going to start seeing wisps of different color, creamy color, inside that liquid. And this is obviously easier seen in the lab than in the field under a slab. But that's what our cream time means. Gel time is when it's dimensionally stable. You can see in the picture here on the right-hand side of the screen that the systems that they mixed in that cup in the lab, it was already dimensionally stable when it hit the top, when it hit the edge of that cup, because it kept rising. It didn't flow over. So that's the dimensional stability. It'll hit that dimensional stability and it'll hold its shape, but it's still green. It's still not cured. It still moves. Tack-free. Surface is no longer sticky. We usually looking for strings, poke something in it to test for that. And then the rise time is just that final little bit of rising at the end. Most of your lift is going to occur between the cream and the gel phase, although it can continue to lift. So the times that we're talking about, cream time, gel time, tack-free, rise time, those are going to be measured for us in seconds typically, and it's going to be listed on our technical data sheets. So on the technical data sheets, provides all the necessary information you need for specifying the foam. There's a description of the project, the applications, unique advantages, reactivity, physical properties, testing mix ratios, processing temperatures, material properties, storage and handling, application cautions. All of these things are really useful because, particularly as winter comes around, we start getting a lot of calls about people having off ratio issues and that kind of thing. And normally we know that starting to get cool outside, the B side starts to get a little thicker as it cools down, and we need to have a heater put on that B side drum. So this is a look at our 4RH. This is it used to be 24-003. We've recently gone through a name change, and we'll talk about that in a minute. This is what it looks like. And on the left side under physical properties, there you see density. We have a free rise density listed here, and then we have an estimated restrained density. Now that doesn't mean it's going to be that. That's just an estimation based on what we've observed in the lab. So 4 pounds per cubic foot, 80 psi compressive strength. So there are many other things on here, and we're going to look at those a little bit. So the installer info, here's your reactivity times. So this particular system is going to hit its cream time in 5 to 8 seconds. That means that it's going to stay liquid for at least 5 to 8 seconds. And that means it has the potential to move further. It's going to hit its gel phase in 11 to 15 seconds, and then final rise time is 25 to 30 seconds. Tack-free, I'm usually not looking at. Processing temperatures, so these are for the installers, processing temperatures. A side temperature between 100 and 120, B side, and then notice that mixing pressure. I mentioned this earlier. 1,000 psi static pressure, but don't want to see it dropping below 800 psi dynamic pressure. And that's when you're pulling the trigger. Application cautions, watch out for putting the foam in too thick, those kind of things, but those are all things that you should be very intimately aware of. Engineering info is what engineers would want to know about the chemical. Notice there's a max service temperature there, about halfway down. Closed cell content, water absorption. Now that's water absorption is just a surface absorption. It's not it's a closed cell foam is a closed cell foam. It doesn't allow water it doesn't absorb water. And then our special testing over here, that shows our GTP9. For the warehouse manager, anybody that's storing the chemical, note this, please. Between 50 and 100 degrees Fahrenheit is recommended storage temperatures. However, before you get out there to shoot, the drum should be warmed up to at least 65 degrees, if not 70. So that's something that can really help you in the winter months, the cooler months, as you make sure that you're storing your chemical. The cold tends to be more detrimental to it than the heat. I mean, obviously, if it's 115 degrees outside in Houston, Texas, and your rig doesn't have an air conditioner on it, I mean, your foam's going to be 115 degrees in the drum, and so that's okay. But from the storage and handling standpoint, if your foam is below 70 degrees, you're going to have a hard time pumping a lot of times. Depends on your equipment. How do you select the right polyurethane? And here is our new names. The new names, NCFI dash, and then we have a number that relates to the density. Then we have a couple of letter designations. So R is a reaction speed, so that's for regular speed. The system we're looking at is 4RH right now. It's a regular speed system. We don't have a fast version of it or a slow version that we sell, although we do have them in our repertoire. But fast, regular, slow, you might see there in that second position. An H indicates that the system is hydrophobic. If there's no H, the system is not hydrophobic, which we'll talk about. And one other, there's an X for our low exotherm systems as well. So those would be for, specifically for large void filling applications. So we've got numerous lifting applications. So why would there be so many? Well, we're gonna pick a polyurethane based on the type of soil that we're dealing with, the type of geology. We're going to look at are we in the presence of water? Are we shooting directly into water, or is there lots of water under the slab or under the structure that we're lifting? What's the application? I mean, where is the application? Right? I mean, if this is somebody's front porch, or it's the truck drive lane at a Love's truck stop, you're gonna have a different probably have a different choice of foam there. So the weight as well, what kind of weight is going to be on it, undersealing, all those things are going to be choices as we look at the different lifting formulations. Now, I do want to say that if most people, tend to keep one, maybe two systems on their rig, but I would say most people have one. And you can can you void fill with a lifting foam and lift with a void filling foam? Yes. Is it the ideal situation? Not always, but oftentimes it is. I mean, a void fill is a void fill as well. But there are different characteristics of our different systems that will give you higher strength, that will allow it to set up in the presence of water, or that will allow it to spread further. Here's a few systems. This is a lot of information on one little slide, so I just wanted to show you that this is available. You can contact us to get a copy of this image. But this is just our general comparison of our most common systems in the geotech side. You can see that the system names are there, correlate to the old names as well. And you can compare the free rise density of different systems, the cream time, gel time, rise time, is it hydrophobic, is NSF available or not? All of those things are on this chart. And of course, the chart information is pulled directly from the technical data sheet. So if you have the technical data sheet, you have this information. So when you're picking a polyurethane, one of the features you can pick for is fast reactivity. Now, as you choose a faster reacting foam, that means that the cream times are going to be in if we go back here and look, our very top line there, look at the cream time in that top line. That's our 2.2 FX, which is basically a spray foam system. That's a low exotherm void fill system. Cream time is 1 second. Compare that two rows down, to 11 to 13 seconds for one of our other systems, the 2.2 FX. So you can see there's quite a big range of cream times, gel time, that kind of thing. So as you use a faster reacting foam, now that can make it really a lot easier to lift. You get pinpoint control, right? The foam's not going to spread as much, which can be good if you're working on a narrow slab. Narrow slabs are some of the hardest things there are to lift with foam alone, because the foam is going to move some. It's going to spread some, even if you're using super fast foam like our 2.8 F. So you do need to watch out, because if the foam can't spread as far, you may leave voids under the slab. So that can be addressed by using either a slower reactivity foam, right? Or if you're using a fast reactivity foam, and that's what you have with you, drill more holes, drill the holes closer together to make sure that you're not leaving void between your injection points. So fast reactivity, you get that instant feedback. You let off the trigger, it stops lifting pretty much. Slower reactivity foams, not necessarily. With a slower reacting foam, if you happen to either be trying to lift with it or trying to do a void fill and it ends up lifting somewhere, that lift can go on for a few seconds, even after you let go of the trigger. But you do get a better spread underneath the slab. So, for instance, our systems that we would use, the 4RH, for instance, used to be called 003. That system is typically used on roadways and other commercial applications. There are residential applications where I might choose it as well, but for the most part, that's like commercial to heavy commercial and DOT work. And that particular system is designed both for strength, initial strength, so 80 PSI free rise, and it's designed for undersealing. It has a slower or a medium reactivity profile where it tends to spread more than a faster system would. And that undersealing is really important out there on the road. Of course, picking for density, density is going to directly relate back to how much compressive strength we have. But it's also, density also affects, very much affects our estimating as well. So lower densities for lower weight applications, general void fill, higher densities for greater load bearing capacity. But just know if you're using a 2-pound foam and you put it underneath something very heavy, that 2-pound foam will pack and could become a 3, 4, 5, 6-pound foam. I mean, it depends. It depends on how heavy it is, how confined it is, and if we can continue to still get foam in the ground. Picking a polyurethane, we'd check for exothermic reaction. The reaction that creates polyurethane foam is an exothermic reaction. That means it gives off heat. So we have systems that are designed to dissipate that heat more quickly and generate less heat during the chemical reaction, and that those can be used for void fills typically. And hydrophobicity. So hydrophobic system, it'll meet the TDS specification whether I shoot it directly into water or not. I'm sure some of you on the call have been around when foam was injected, a non-hydrophobic foam was injected into water, and that it doesn't turn into foam. It's certainly not solid. Let's put it that way. It tends to string out, get really gooey, and there's no structure to it. So non-hydrophobic foams are not going to make foam if you pump it into water. Hydrophobic system will, and should still meet the technical data sheet specs. And that's where that GTP9 test comes in. It's really important to note this only applies during the chemical reaction. All right. So hydrophobic systems don't mean that it's waterproof. Hydrophobic means that during the chemical reaction, if there is excess water present, it's not going to interfere with the chemical reaction in a way that causes the foam to not meet our specifications that we designed it for. So, but after the fact, after it's foam, you know what? Hydrophobic doesn't make a difference anymore. It doesn't apply here. After it's foam, foam is a moisture and air barrier. Closed cell foam is. So that hydrophobic systems are going to be really useful when you're shooting directly into or around water. Now, if you do have a non-hydrophobic system, in fact, our most popular system is not hydrophobic, the 2.8F. But it doesn't have much problem in water because it's so fast. It tends to, if you're trying to stop a leak with it, it wouldn't be good for a void fill in water, but if you're trying to stop a leak, I've actually stopped leaks with that non-hydrophobic super fast chemical, stopped active water leaks with a non-hydrophobic system. I wouldn't use it for void filling or lifting in water. All right, we're also looking at our project goals. What is our project goal? If we've got a slab lifting and realignment. In this picture, we're pumping pretty close to the adjacent slab. We have some differential settlement there. We're trying to lift one slab to match the other, and so a fast foam can really help here because a slower foam might get under both sides and lift both. Also, what kind of weight are we looking at? Is there water under the slab? Those kind of things we need to look at as well. Is this a void filling application, just like a pure void? In that case, if you have thicker, need to put in thicker lifts, you can use one of our lower exotherm systems. So there's 3 versions of those. They're all 2.2 pounds per cubic foot, but they vary in speed, hydrophobicity, and not so much density, but somewhat. Soil stabilization applications. This could be in the right type of soil. This could be a single component application, but we're looking primarily at deep injection with 2-component foam, dual component foam. So stabilizing or I should say densifying soils, stabilizing structures. One thing to point out, in some markets, soil stabilization is becoming has been used by about high PI clay. So if you have a high PI clay, there are chemicals that can be injected to lower the expansion coefficient of that high PI clay. And in some markets, soil stabilization means not polyurethane, but it means those chemicals. So watch out for that terminology. We can also use it for increasing load-bearing capacity or densification at depth. That's an indication of deep injection. We've got 3 levels of deep injection. So now instead of slab lifting, we're also going to be going deeper with our injection points as well. So not just a horizontal grid, but a vertical grid. Wanted to take what we have learned so far and apply it to bidding a project with slab lifting. And this is just an imaginary project, but how do you figure out how much foam it's going to take? Well, so that basic formula you can see, length times width times the average depth. Okay, so I need square feet first, right? How many square feet am I working in? And then across that area, what is the average void space or lift that I'm going to need to have across that entire area? So that's sometimes hard to determine, but we'll look at that as well. PCF is pounds per cubic foot. That is the free rise density of your foam. So length times width times height, average depth, right? That's height, times the free rise density of the foam. That's the calculation. Now, there's a lot more that goes into getting good at the calculation than that. But you know what? These days, pretty much don't use anything but a calculator to estimate projects anymore, because it's a pretty straightforward calculation. So in this case, our 24044 or the 3RH, so it's a 3-pound regular speed hydrophobic system. It's a 3 pound per cubic foot system, and that's free rise density. So if we had a 40 by 80 slab, it's down an average, we figure, of 2.5 inches. That could be void, or that could be lift, or it could be a combination of both. And we'll talk about the difference there. But that 40 by 80 by 2.5 divided by 12, we had the 2.5 divided by 12. Don't forget, you got to turn your 2.5 inches into feet. And we've got a 3 pounds per cubic foot system, free rise system. That gives me 2,000 pounds of the 044 or 3RH. And so it's a pretty straightforward calculation, but look at it. It's really important. Number one, that okay, get a good idea of the area that you're going to treat and how much void is there. Now, finding out how much void is there often isn't possible until you actually get on site to do the job. There are methods you can use to everything from banging a hammer on the floor to tapping a big metal rod on the floor. But there's nothing like drilling into the soil or through the concrete to find out how much void is actually there. And in most cases, you're not going to be able to do that beforehand before you're quoting the project, but some cases you would be. So that density, though, is going to be really important to us because it's going to go directly to how much foam we're going to be estimating for this. You can see that we estimated the free rise density using the free rise density. So if you think of free rise density as the minimum density that particular polyurethane system should be when it's processed properly, that's what the density is. That's the free rise density. Well, now I can look at that and I can say, well, I've got 2,000 pounds at free rise density. So that's what I just calculated. I didn't calculate how many pounds it's going to take to do the job. I calculated the minimum amount of pounds it's going to take to do the job, assuming that all of my other numbers are correct, right? So, it's 40 by 80. It's 2.5 average. Maybe it's 3.5 average. I don't know. Maybe I missed that. But it's still going to give me my minimum, assuming all the other numbers are correct. Need to account for added costs as well. So this is where your free rise density becomes something more. You're looking more than the free rise density, and we need to adjust for packing, right? So the 3RH is a 3-pound foam. Under confinement, it could be 3.1, 3.2, or more. And literally, I'll tell you, back when I had my business, this was probably around 2007 or 8 that we did this project. But there was one project that we did with a 2.8 pound foam or 2.5 pound foam, something like that, and we lifted 72 tons with that system. Now it was just a 2.5 pound foam. It was a simple lift. It wasn't a difficult lift. It came right up. But that 72 tons was the lid of a big steel lid that had to be lowered by a gantry crane onto this rack that we were stabilizing underneath. And that foam, we shot it with the lid on top of the concrete. And so I know, and then we lifted. And so I know that foam densified beyond that 2.8 pounds or 2.5 pounds per cubic foot. I know it had to, because that lower density would not have overcome 72 tons of weight above it. We recommend doing lump sum versus per pound quotes. There's a lot that goes into that. You can create. We recommend banking unused pounds sometimes. So that you don't have to use charge people overages if that's the case. So lump sum is definitely a better way to bid it than per pound. Some people bid it by the square foot. That still tends to be sort of a what would I say? Square foot it still makes it more commodity rather than lump sum, because who's to say that the next person that bids, that comes in after you, is bidding apples to apples. They may be using a lighter weight foam or a system that's not good for that particular application. They may have estimated the void differently or estimated the square feet differently. So you're not always going to get right on with your estimation. But if you do have pounds left over at the end of the job, it's your choice. Do I give those back, or look, I keep those pounds and I bank them for next time, so that I don't have to charge the next person an overage if I do go over it. Options. We have projects bidding spreadsheets. If you have multiple areas, this is, you can contact us to get a copy of this, and a web app as well. And Robert, what time are we going to start the Q&A? Are you there still?
Sure thing. I'd like to get started in about 3 to 8 minutes.
Okay, 3 to 8 minutes. Not 8.5?
So 15 till or 10 till.
Got it. We're going to look briefly at how we might approach lifting, the injection design to just lifting a slab right now. And of course, we do at least 2 schools a year at our facility down in Houston, Texas, and we're also building a new plant right now that's even bigger in Mount Airy. I just heard that our sales support folks moved into the new officing last week, so that's pretty cool. Things are moving along out there in North Carolina. So looking at our injection approach, just if we had these elevations, how do you get these elevations? Typically, we're going to use a product called a zip level. Mosier is another tool. There's various ways to get these elevations. They don't need to be actual elevations based off of an actual anchor point or base, but they do need. It shows me the contours of the slab, and so as I look at that, I'm going to develop a grid pattern. If I'm using a fast reactivity slope or actually, my first thing I'm going to start 12 to 18 inches off the edge. Not off the corner necessarily, but not off that radius to the corner, but off the edge. And then with a fast reactivity foam, we're going to be typically on a 3 to 4, maybe 5 foot grid pattern. With our 2.8F, that used to be called 24-010. That one you might be on 3 to 4 foot grid patterns, depending on, in the summertime or something. It's a faster system. But if you go with the wider points, the wider grid pattern, you can always put a hole in the middle. You got 4 points, make it look like, put one in the middle of those locations if you find that your fast reactivity foam is not spreading far enough. A slow reactivity foam, the main thing you got to worry about there is making sure that you don't overlift in the wrong place, as it does travel further. Your grid patterns can be adjusted to your particular project, so that is not a hard and fast rule. Typically, we're going to start where the lowest point is. There may be void there may not. It really just kind of depends. So at some point, there's various reasons that slabs settle. In a lot of cases, it's due to water, which may create voids. It can also, consolidation of fill on itself. All fill consolidates somewhat even after being placed. And so that could be causing the problem as well. So we're typically going to find that lowest point and begin our injections there. That's because concrete is structural, right? And so if I lift, if I'm lifting right here on this, in this spot on this concrete slab, can it also lift over there where that other injector is depicted in the concrete slab? Absolutely. It's going to lift some there as well. So that's why we start at the lowest point, because if we start at a high point and we begin lifting there and get that up to our level, and then we go and start lifting lower parts of it, we can actually overlift the first part that we lifted. So this is not a hard and fast rule. Again, you don't always start at the lowest point, but 95% of the time. All right. As you lift, remember that's going to create void. So those voids need to be filled back in. So after you've lifted, say you're working on a drive lane at a distribution center. So you got 18-wheeler trucks going along there. As you lift, you're going to create some amount of void. So you may need to go back and do stabilization shots to make sure that you got full coverage underneath the slab. Of course, using a slower system, drilling extra witness holes to see if the foam comes out as you're injecting. There's different techniques you can use to work towards that. What we don't want to do, though, is leave big voids in between the different injection locations. We want to make sure that we're filling that. Foam works by spreading the load. And so spreading the load here means that we don't have to have every single bit of concrete covered underneath, but that's our goal. All right. Robert, I've got a number of these, but I can just go through one or two, or if we're ready, let me know.
I think these are important. Let's just try to see,
Okay.
Get through them as fast as we can.
Right. This is a void fill project, Crown Plaza. They wanted to make the pool smaller. They brought in some rubble, used 24039, which is one of our lower exotherm systems. It's also now called 2.2 SHX. So, but we use those to fill voids in the rubble. Then they came in and they poured a slab over the top of this. So filled up the entire pool. So that was a neat project. Here's another big void fill. This one used our 24003, which is now called the NCFI 4RH. We used 7,000 pounds of that to after a water line blew out underneath this chicken plant slab, and 1,000 pounds of the hydrophobic void fill. 24039 used to be 2.2 SHX. Here's another one. This is underneath the Biltmore Estate. If you're familiar with that, this is the Biltmore Estate location, and this is their spillway. We used the 039 because it was a wet environment, and some of the 4RH or 003 as well. Both those are hydrophobic systems. Another culvert, a void fill in a wet environment. Here's a stabilization. They shot to get heavy equipment into this location first. They already knew there was void underneath this slab. So they used the 2.8F to stabilize the slab so they could get heavy equipment in to drill and determine what the next steps are. Next steps turned out to be, hey, we're using 2.2 SX, which used to be the 070. It's a low exotherm void fill project. We can also stabilize footings, lift footings as well, stabilization. This is a project that we did up in the Wyoming area. But this project, we had to drill drive deep injection tubes at an angle to get directly below the wall of this two-story building. Once we determined that angle and started injecting, we were able to stabilize the slab. And by stabilize, I mean we were able to lift just a slight amount, just to know that we had filled all the voids and had stabilized underneath that, not the slab, but the footing. It was a narrow spread footing. I think it was 18 inches wide, if I recall. And another big flat work job. This one's a 55,000 square foot warehouse project. You can see that we treated that entire area, most of it, I would say. And so this was a big project. You can see the outside there is on 4 or 5 feet of fill. This project is also right next to a large body of water. And so we figured water might be part of that as, the causation here as well. That center picture, you can see we had between 3 and that's 12 inches of lift that we needed to get out of this one. So that 12 inches of lift area down there, we started at the other end. We started with the 3-inch side. But that took 4 rigs working quite a long time to make that project happen. There was, I can't even tell you how many holes they drilled. I don't recall the exact number, but there were so many holes drilled in this particular application. It took a long time, and we used 4 rigs to do most of it. And last but not least, we got a C-camp pile wall. This is down in the ground. They drilled these concrete columns into the ground and then excavated from in the middle of it. And one side on the right there, that's dry. That's the way it's supposed to be. On the left, it's not. So they had water coming in. You can see it's quite a bit of water coming through between the different columns and the C-camp pile wall. They had tried stuffing oakum other things in there. The flow was too hard. It was pushing it out. But we did end up getting it plugged up using some wood shims to hold the oakum in. And you can see we got that water cut off. Now, this was a single component project. This was our 24-120 or NCFI 120 that we used. It's moisture activated, and it was injected just with a paint pump down to the bottom of that pile wall. And there we go.
All right. I think it was worth going.
No, I had to hurry through those last ones a little bit, but I don't want to keep y'all too long.
Yeah, absolutely. We've already got a few questions already in the hopper, so appreciate those that were submitting them through. If you do have any questions, please click the Q&A button down at the bottom of the screen, enter your question and hit submit, and we will ask it on here. The first question I have is, if the formula is the same, what makes it NSF?
Yes. Okay, so the formula there, yeah, I know I didn't finish that part. I got thinking about something else. Yeah, so NSF, there's no chemical difference between our, you know, 4RH NSF or 4RH regular non-NSF. The only difference is how we clean the tanks, the blend tanks, to make sure there are no contaminants. And so what that effectively means is that the chemicals, the polyurethane foam is pretty much environmentally inert as polyurethane foam. So it's during the blend process. It's not a chemical difference. So
So
even non-NSF systems, if they have an NSF version, they don't conform to it, but there's no difference except for the
so
blending.
as I understand it within SF, it's just like any other, like an ASTM standard or something to that effect. Mainly, to ensure that a certain standard of quality control is made in the blending process, that no outside potential contaminants get involved within the formula itself, which it allows for that NSF certification. Is that an accurate statement?
Yeah, I would say so. I mean, we have it's third party certified. So we send all of our information out for testing and review, and we keep that certification up as well. So there is a third party. Ours it's currently through ALS.
All right, wonderful. Thank you. Where does the water go when filling behind a bulkhead? Does it push it out?
Yeah, and so yes, it pushes the water out of the way. So most polyurethane foam is going to work by displacing water. It will float on the surface if you got a chunk of it. Yeah, it's gonna displace the water and push it out of the way. I had a project that we did in 2010. It was a deep injection project, and we had water 11 feet down, and we shot deep injection down to around 10 feet on the weekend number one. We were working over the weekend. And then we came back the next weekend and found that everything we shot the weekend before had dropped back down again. We started looking at causation for that, and what we determined, and we proved out to be the case, is that we had gotten a hydrostatic lift through our deep injection process. There was enough water under the slab that we actually lifted the slab by pressurizing the water, and then over the week that we were gone, that pressure dissipated into the surrounding soils. And so, yeah, I mean, it can create a lot of pressure and enough pressure to lift. We went back with a different application method. We changed our technique. Nothing else did we change about that. We just changed our technique a little bit and resolved that problem. And
But I want
didn't have that problem at all.
But I want to clarify that lift situation occurred because you confined the water underneath the slab and there was enough pressure to help lift against it. Is that an accurate
Yeah,
statement
in
to what
fact,
you?
yeah, and in fact, it was confined on all four sides by shale. I mean, this was in Arkansas, where my business was,
So so
and
in a sit so if you don't mind, if in a situation of a bulkhead, you're typically not going to have that kind of issue. You're going to be chasing the water down the line, or the water is going to be getting pressure through either openings, any kind of gaps that's in the concrete or slab or whatever it happens to be. But you're basically moving the water. The water's going to go where the water goes, and it's usually the path of least resistance. Is that a
yeah, I would say it's unusual to have a situation like that, but it can happen. So in general, though, the water is just going to be pushed out of the way pretty much immediately.
how do you typically estimate the void space when bidding a project?
Great question. You know, there's it's really hard to estimate. What I do is I will estimate. If there's any lift to do at all, that helps. Okay, because that gives me at least some dip that I need to account for in how many pounds of foam I bid on this project. But even if there's no dip in the floor that I'm supposed to relieve, Look, you aside from drilling a hole, um, it's really just taking that square feet, getting using your free rise density and estimating how much you think uh, would take to lift that structure, and then you an overage on top of that. Now, of course, if you can drill a hole, you can measure that void with with a rod or with your drill bit. You can stick a little camera down there and look at how much void is there. But yeah, I mean, it takes some doing to estimate the void.
Yeah. And, along with that question, there was how do you assess the amount of foam that will be accepted by the soil?
So obviously, pore space is important there. Pore space in between the soil particles. So clay soil is going to take, it's going to accept less than sandy soil, or you go to that Crown Plaza project we looked at briefly. You've got huge pieces of, the riprap, big pieces of chunks of rock that we're trying to fill in between. And so that, the pore space is going to be important, but honestly, two component foam is mostly going to force its own way in. It's not going to really soak into the soil in any way. We think of that as compaction grouting. It's a rapid expansion that creates pressure and can generate lift as well. With single component systems now, those tend to be lower viscosity. And in the right type soil, not clay soils, but in sandy soils where you have quite a bit of pore space between the soil particles, then that is designed to soak in and lock the soil together into one piece. So two component does that somewhat, but not nearly the same as single component would.
Great. I do want to go on ahead and give a break just for people's time. We are past the 12 o'clock or the 1 o'clock timeline, the 1 hour. Again, if you're wanting your PDH certificate, please, as you exit the webinar, it'll take you directly over to our survey. Please fill out the survey. That's how we can indicate whether or not you're PDH, and also for our tracking accountability. We'll also be sending a follow-up email as well. But we're going to go. We have plenty more questions, so we're going to continue on. But I just want to out of respect for people's times. Okay, I got a question of, can I get a copy of the presentation? Yes, please just indicate to us that you'd like one. You'll be receiving an email directly from me. We'll make sure it gets over. We may even send out a PDF version, link to a PDF version post-webinar. Next is, can we get a copy of that spreadsheet with the different foams and density? Yes, we'll follow up on your question there. Make sure that you get that. It'll also be a part of the presentation if we decide to send that out. And then, and you're always welcome to reach out to your local sales rep to make sure that they can get you those also. Okay. Are we going to get one part for seawalls in South Carolina anytime that you'd like? I think that's pretty well available. Just contact your sales rep.
It's there.
Yeah.
It's there.
Then if we don't get enough lift, can we inject into the same hole again?
Yeah. Now, with the mechanical purge guns that we recommend, you would have to re-drill the hole in a lot of cases. But certainly you can re-drill the hole and inject. You typically want to try and inject, drill all the way through the foam you already shot and get underneath it. Because oftentimes the foam tends to stick to the bottom of the slab, and you may not have enough room to get it in if you don't drill far enough. It may blow back out at you, in other words. Yes, you can inject into the same hole again. Now, there are air purge guns and water purge guns that are available there as well. And those will keep the hole and the port that you're using to inject into the hole, the water or air, would keep that open. So you could continue to inject even after, minutes at a time. My problem with those sorts of things, there's a use for an air purge gun. There's a use for or air or water. I put those together. It's a preference, and then or the mechanical purge gun. So we recommend the mechanically purged guns. They're not nothing that we recommend is proprietary except for our foam.
Okay.
So you can get it from anybody.
Can waterproofing be done with this PU foam method on the positive side? If yes, how is it done for deep grouting?
Yeah, as a matter of fact, back in the day, we used to with two component foam, we would seal the outside of manholes with the two component foam. That was when I had my business. It's certainly used all the time. Single component, I see that really taken off for the positive side type water stop. That single component side of things is we have experts in two component and single component on our team. So in those cases, we'll defer to those experts. But
It is
so
you. But
yes,
it is
it
you.
can be done, and it is being done right now.
Yeah, and it's been used in a variety of factors, whether it's culvert, basements, elevator pits, tunnels. There's quite a bit that's being done waterproofing positive side.
Yeah, and then you can go down. I mean, you can drop down into the structure and drill through the wall, or you can go down from the outside with a tube and seal it from the outside.
Compaction versus permeation grouting. What side factor is the driver for choosing each method?
It's really the type of soil, and what you're not going to be doing permeation grouting in your smaller particle soils. So it's something like 3% passing a number 200 sieve is gonna that's pretty much your limit for acceptance on some systems. It depends on the viscosity of the system, but so there are it's mostly soil type, but it's also your goals for the project and honestly what you have with you. I'll seal a hole in a basement. I'll seal a crack in a basement wall. Typically would use a lower viscosity single component system for that. But if I had my rig with me and I didn't have any single component with me, I would probably shoot it with the two component. But technique is different when you're shooting a two component water stop versus a single component. So there's a lot of technique to that as well.
Yes. Okay. And I think goals is important, right? Are you trying to achieve lift? I think in a permeation
well,
situation.
that's a good point. Yeah.
Yeah.
You're not going to lift with the single component systems.
If milky water comes out after injecting foam, even when using the hydrophobic system, how can it be fixed?
Not sure. I'm trying to think of what would be milky water. It may be. So if that happened one time, it could be maybe you were a little off ratio. As if you're off ratio when you inject the foam into the water, it's not going to be as hydrophobic. Some systems are not as hydrophobic as others. So it could be, depending on what system you're using, it could be that maybe that leading edge was not as hydrophobic as the rest of it, and maybe it strung out a little bit. Now there is a sheen that tends to come on top of the water. We have verified that is a catalyst, and it's not at least with where our foam is concerned, that's a catalyst. I believe is what I was told. And that sheen on top of the water will dissipate. It's a surfactant. That's what it is, because it's the same as that we use to break up the oil for oil spills. If that's what you're talking about is milky water, that's not milky colored though. That's sort of rainbow colored.
Sure. And I can say there are some instances we've seen where, and doing culvert injections or doing areas where you've got a relatively high flow rate with groundwater or some other flow rates. What you can do is do some shorter shots to try and get the material itself to gather on whatever structure or whatever material that you're working with. And because of that shorter shot, hopefully there's reaction. It gives it something to cling on to. And then the adjacent shots that come after that will cling on to the existing material that you're having in place. So it can be done through some technique in order to get the poly to adhere and react.
Yeah, I
Uh,
mentioned I stopped an active water leak with a non-hydrophobic fast foam. I was up in Canada a couple of years ago, and we were down inside a tunnel, and it wasn't part of the project, but it was water pouring down on our heads that wasn't supposed to be there. So what we had in our line right then was 2.8F non-hydrophobic super fast system. So we put about a 10-foot piece of steel on the end of the gun to give that, or 8 foot, I guess, to give the chemical time to set up and start to really react by the time it hits the water. And so the closer it is to foam by the time it hits that water, the better the performance is going to be. The leading edge is still going to be milky, mush, gooey, but we completely shut off that water leak overhead by using technique instead of a hydrophobic system.
in a concrete slab lift, what diameter holes are common?
I have some customers that exclusively use the 3/8 injectors, and most of the time 5/8 has been the de facto standard since I was in business. Started business in 2006 and before. 5/8 seems to be the standard in most cases. Although for residential work, hey, those 3/8 injectors are really great. The 5/8 tend to hold on better. Watch out for the 3/8 slipping out of the hole on you. But the 3/8 are really nice, particularly if you have like narrow grout lines you need to drill through. Much smaller hole. Same volume of foam getting through the center of the packer or injector, but it's a lot better. So
Is cell structure and compressive strength affected when the resin reacts in the presence of water?
it, is it affected? I would say I'm not a chemist, so I'm not going to say yes. I would say it is as a layperson. I would think that it's affected, but how bad it's not affected enough to not it will still meet the technical data sheet. So if we publish or sell a hydrophobic system, develop a hydrophobic system, we've tested it against that GTP9 test. So yeah, it's going to maintain the same print properties on the technical data sheet, whether it's shot into water or not.
When it floats, is that a sign that it pushed out? That it pushed it out?
Could be. I think what Tracy's getting at is, maybe there was some excess foam or something that got out. We definitely recommend if you're shooting next to water or into water, that you use a boom around on the surface of the water to catch any stray particles of foam, because it can become a lot. You can, if you let it go, people have used dip nets. Of course, the dip net stops working after, picking up 5 or 6 dips of foam because it coats it. So yeah, we recommend and sell those yellow floating booms for the surface of body of water to keep all that stuff contained, so it doesn't go downstream or out into the lake or get on somebody's boat. That you really got to watch for that stuff.
Yeah, and I think beyond that too, though, is I think it depends on the goal of the project. If you got cracks all over your seawall or bulkhead, or you've got loose joints, and one of your aspects is try to seal those cracks or seal those joints, you're going to get travel, and you're going to want to have a second pair of eyes continually monitoring the water flow, looking for when material starts to float or when they get a sheen or anything along that lines, because that is showing that the material is permeating through somewhere.
Mm-hmm.
And as you're walking down the wall, you inject, you have a certain setup time, and you move along the wall again, and then you start seeing it come out. But that's because it is addressing the voids and the cracks, and is operating and sealing it. And so I hope that's helps as well. Uh, for deep soil consolidation grouting, 2, 5, two 5
Yeah, I see
meters
it.
and 5 and 0 meters.
Oh,
Okay. For soil consolidation grouting, if the void content of the backfill material is defined as 30%, how do I calculate the confined expansion rate of the PU?
who asked that question?
Uh, I would,
Yeah, we're gonna punt on that one just because um, that gets way out of the scope of what we're doing here and would take a lot more explanation. Um,
well,
that
that being
said,
said, though, we would love to support it. We have certainly engineers that we work
yeah,
with that are more than happy to help work with helping you identify what that material and that confined expansion rate would be. It's going to depend on a material by material basis as well, because some have certain expansion rates versus others. But we will definitely get back to you. So thank you.
yeah, but
Um,
the general calculation again. I mean, you've already said that the void content is defined as 30%. Well, what's your area and what's 30% of that, and what pound foam are you using? I mean, it's going to be the same type calculations, but there's more that goes into that.
sure. If milky
But we would
water
love to
comes,
work with you. That's we. Sorry, Robert, but I mean that's what we do. We definitely would love to work with you and can help you in that design process.
sure. If milky water comes up during injection, is it a problem? Not necessarily. I mean, if you're in a situation where you've got boom, as we mentioned before, you're collecting it and you're observing it to make sure that it doesn't enter water in any kind of pristine water environments or anything along that lines. It isn't. But you do want to just make sure it's just not continually flowing because you are watching to make sure that the material is setting up, such as in the instance that Kevin showed at the end there where they ended up applying the shims in order to give it a gather point for the material. Had they not done that, then you would just continue to watch, milky water probably coming out because that is the material itself. So
I'm
it'd
I'm
be feel
wondering if maybe this is a high flow leak that we're discussing. This person's asking the question about. If it's a high flow leak, it may be the foam, pouring out and not sticking to anything and just going downstream. So that is a possibility. I've certainly done that where we couldn't get the foam to stick anywhere, and the flow was so high that it just kept carrying it downstream. And we were working in a sanitary sewer manhole, and we got a call from the folks down at the waste treatment center saying, "What's all this stuff floating in our pond?" So,
yeah. So maybe an indication it's not setting. So you
right.
may need to adjust, certainly. Is cell structure and compressive strength affected when the resins react in the, oh, sorry, forgive me. That was the same question as before. How to avoid staining the top concrete after injecting the foam?
Okay. Um, so number one, no leaks. Watch for leaks. If you got leaks, you need to work on your equipment, or at least put your gun in the bucket. Keep it in the bucket if it's leaking and you can't stop to repair right at that point. Water. Most people just spray water on top of the concrete or anywhere that you think it might get foam. There is also a product out now. I have seen it used. I haven't used it, but there's a product out now. Who is that? I can see the logo, but I can't remember the name of the company. But I'm sorry. They make the spray foam release, but they sell a product that does that. It doesn't do it better than just plain water. I don't know. I haven't ever evaluated that, but all of my time doing this, I've just doused it in water, and the water helps keep the chemical from sticking.
Yeah. And then any foam that's set, they'll go by with a metal brush and clear it as well.
Oh yeah, Tom texted me. It's Chemtrend's product.
Thank you. Thank you, Tom. Are the ASTM tests done in house or by a third party?
Yes.
Both.
Yeah. I mean, all of our testing, most of our testing is done in house, and so we're self-certifying in a lot of cases, but we also have third-party testing in a lot of those cases as well. So, for instance, PFAS. forever chemicals. That's something we don't test for, and don't have the ability to test for. So that's all third party. And of course, our polyurethane systems do not have PFAS in them. So there's no forever chemicals in these.
For estimating a project without drilling an inspection hole, how do you put in a caveat that you can modify the quote once inspection holes are drilled and you find a very large void underneath?
Yeah, I mean, I always put an out clause in my contracts, basically saying no harm, no foul. In the case that we find, we expected to find a coffee cup size void, and we found a Volkswagen size void instead. In that case, I have the right to pull off the job. I'll make it look right, patch the holes, whatever. No harm, no foul. You don't owe me anything, and I'm going to reevaluate my proposal. Talk to your lawyer, look at local regulations. But yeah, I mean, it's you moved that question. Hold on. What was the question?
Oh, I'm sorry. Yeah, it was for estimating a project without drilling an inspection
Yeah.
hole. Do you put
All right.
in a caveat that you can modify the quote once inspection holes are drilled and you find a very large
and
void
so
underneath?
yeah, and so the language itself is not as important as just what you just said. Basically, you're going to put some language in there that allows you to either pull off the job or reevaluate if something unexpected occurs. The other way to do that is to say, we bid 200 pounds on this project. It took us 300. It looks like it's going to take us 300. So I'm either going to go to my foam bank, my pounds bank, and apply that to this customer, or I'm going to ask for a change order.
Yeah. I mean, in other ways
Trouble
too is
residential customers and change orders that doesn't go over well.
but some other ways too is, upfront communication. If you are walking into a situation where site conditions are unknown because you don't have a soil report, there might be concerns that there's a void or something to that effect. You need to preliminarily stated, even in your contract, that this is based upon the site conditions as known. As site conditions change, this may change our overall approach and the overall costs and negate the ultimate value. But, in those situations, if it's able to be pre-communicated and you think that there might be a potential void there, bring them the appropriate material along, communicate with the homeowner ahead of time or the engineer ahead of time. And then, try to coordinate with them if they want you to go on ahead and finish the job with the rate. And then you can operate on a per pound basis at that point. That way, it's good upfront communication. Communication is key in all these instances, and it allows you to complete the job while you're there. So
yeah, setting expectations with the customer and maintaining, the definition of success that I have in my mind is the same as the definition of success that they have in their mind. That's important.
Well, that is it for our questions for the day. I want to thank everyone for hanging out with us an extra 22 minutes. That's fantastic. Really appreciate your attentiveness and your willingness to hang out with us. Again, if you have any questions, please feel free to email us. We're glad to handle any questions post this. Also requests as well. If you are looking for the PDH certificate, please fill out that survey, post the webinar. Thank you again for joining us today. We enjoyed having you. We hope the information was useful. So thanks so much. Have a great day.
Thank you. Bye-bye.